Hello students, welcome to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So yes, we are now doing one of the most important topic, that is alcohols, phenols and ethers, and today is going to be the very important video on chemical reactions. Okay, so this is a part from where majority of the questions will be asked. So we'll be covering all the reactions and then we'll be practicing a lot of questions also. Okay, so yes, please join our WhatsApp channel. The link of the WhatsApp channel will be there in the description section of this video, so please go there and join the channel so that you will get all the notes and you can get the question paper, solutions, everything in our WhatsApp channel. Okay, so yes, now please sit with a notebook and a pen, and so that you can make notes of all the important reactions and you can practice questions with me. Okay, so now without any delay, let's get started for today's class, which is very important, that is chemical reactions. Okay, so as I told you, how are we going to cover this chapter? So every part I am explaining this is important so that you can understand how you should revise the chapter. Okay, what all things should be there when you are revising, you do not miss out on any important thing. So that is why we have divided this chapter into 4 different parts. Okay, so in the first part we have already discussed classification. One second, yeah, so we have already discussed classification, nomenclature and structure, right? In part 2, in the last class, we have discussed preparation of alcohols, the methods, preparation of phenols and physical properties, right? Next, today's important reactions, that is very important, we will be discussing chemical reactions of alcohols and chemical reactions of phenols. Then coming to part 4, here we will be covering commercial alcohols and we will be covering most important topic again, ethers. Okay, I hope this is clear. So now coming to the today's weightage year wise, so you can easily expect 3 to 4 questions from this particular chapter. Okay, so a very high weightage topic, and organic chemistry, like almost you can say 20 questions you can expect from organic chemistry, and it will be mixed from all the 4 chapters. So that is why it is very important to master all the 4 organic chapters that you have, right? Okay, next coming to today's lessons, that is chemical reactions of alcohols and chemical reactions of phenols. Okay, let us move ahead now. So now see here, first point, alcohols can behave both as nucleophiles and electrophiles. Okay, so what is nucleophiles? I hope everybody would be knowing. Nucleophiles means electron rich species, right? And they can also behave as electrophiles, that is electron deficient species. Okay, so now we will see how alcohols can behave as a nucleophile and how alcohols behave as a electrophile. Okay, now see, first alcohols as nucleophiles. The bond between the OH, okay, you know the structure of this ROH, right? R, this is alcohol. Okay, the bond between OH is broken when alcohol reacts as nucleophile. So the point here is, if alcohol is behaving as a nucleophile, then this bond will break. Okay, this OH bond will break and the lone pair on the oxygens will attack. Okay, that is why we call it as a nucleophile. Alcohol is behaving as a nucleophile. So which is the nucleophile? The lone pair present on the oxygen will attack on the other species. Okay, so now you can see one example here. This is alcohol, this is the lone pair on oxygen, and this is what? This is an electrophile. How can I say this is an electrophile? A carbon with a positive charge, right? Carbocation, a deficient electron, deficient species. Now what happens here? This lone pair of electrons attack on this carbon. Okay, so now you can see this is formed here. After this, this H plus will go. Okay, this H plus goes out and we get RO, then see this one. So you see what is happening here? Just it was like this, ROH was there, right? So in place of this H, this new group has come, right? So I can say this OH bond has broken and a new OC bond has been formed. So in the case where alcohols behave as nucleophile, the OH bond will break. Okay, now if alcohol behaves as an electrophile, okay, the bond between CO is broken when they react as electrophile, protonated alcohols react in this manner. So what is protonated alcohol? See, when you have any alcohol in presence of H plus, okay, this lone pairs of electron are there, it will attack on this H plus and we get R CH2O plus H2. This is nothing but your protonated alcohols. Okay. Now why it is called protonated alcohols? Because you have added one H plus to the alcohol. Okay, H plus is nothing but proton, right? So when we have added this H plus to this alcohol, we got protonated alcohol. Now what happens? This is your CO bond. Okay, so this bond breaks. This bond breaks when it is behaving as an electrophile. So here this Br minus is behaving as a nucleophile. Okay, this nucleophile attacks on this one and this bond breaks. So now you see we got RCH2Br. So what was there before here? RCH2OH was there, right? So now this bond has broken and in place of this OH, Br has come, right? So that is why we say that when alcohol is behaving as an electrophile, the CO bond is breaking. When alcohol is behaving as a nucleophile, right, at that time OH bond will break. Clear? Let us revise it again. If it is behaving as a nucleophile, then which bond will break? OH bond of alcohol will break. If it is behaving as an electrophile, then which bond will break? RO bond will break. Clear? Okay. So now we will see these reactions in two cases. Where OH bond is breaking, what all reactions can happen? When CO bond is breaking, what all reactions can happen? Okay. So coming to the first one, when there is OH bond is breaking, means this is electrophile or nucleophile. When alcohol is behaving as a nucleophile, right? These, and then when we have CO bond, that is when alcohol is behaving as electrophile. So in the cleavage of OH bond, we have reactions with metals. Okay, we'll see the reactions with metals, acidity of alcohols and esterification. Okay, these three reactions we will discuss. Next, coming to with cleavage of CO bond. So here we have reaction with HX, then we have reaction with PX3, dehydration and oxidation. Okay, so let us recap it again. So alcohols can react in two ways. One is cleavage of OH bond. In cleavage of OH bond, we will mainly discussing about reactions with metal and we'll be talking about esterification reaction. Acidity of alcohols we'll discuss. It is not a reaction. It is how to predict the acidity that we can discuss. Okay. Next, coming to cleavage of CO bond, where there is CO bond cleavage is there. What all reactions are possible? There you have reaction with HX, reaction with PX3, dehydration reactions, and you have oxidation reaction. Okay. Once again, let us revise. When there is cleavage of OH bond, there are three types of reaction. Reactions with metal, acidity of alcohols, esterification. When there is cleavage of CO bond, there are four types of reaction, right? First is reaction with HX, reaction with PX3, dehydration reactions and oxidation reaction. Okay, so here you just remember, here we will be not studying any reaction, we'll just discuss here. No reactions are there here. Okay, so here you can see two reactions and here we have four reactions. Okay, four types of reactions. Okay, so now we'll start with reactions where cleavage of OH bond is there, means where alcohols are behaving as nucleophiles. Okay, so now if you see here reactions with metal, okay, so what happens here? This oxygen, this OH bond will cleave, right? So I'll get RO minus and we'll get H plus. Okay, and here sodium is there, so sodium will take this O minus, so we will get RO minus Na plus and H2 gas is produced. Okay, that is the first thing. Next, these all things RCOH, RCO whole 2O, RCOCl. What is this? This is your acid, right? This is acidic anhydride, or we can just write anhydrides. Okay, this is anhydride and this is acid chloride. Right. So now what happens here? Alcohols react with these three things. You have to remember all the three. That is your acids, anhydrides and acid chlorides to form esters. Okay, so these three reactions are your esterification reaction. Esterification. Okay, so now what happens here? Simple, just you have to take this RO part, okay, and here you have to take RCO part. Okay, so you can see RO from this acid part, from the alcohol part, and you have then COR dash, this part. Okay, so this will give you ester. Okay, similarly, if you see this side, we have taken this RO part, from the RO part is from your alcohol, and then R dash CO, this part is from your anhydride. Similarly, here again RO part is from the alcohol, R dash CO is from your acid chloride. Okay, so by this way we can get esters. Okay, so what is the reaction here? One is reaction with metal, sodium metal, it will react. Another three reactants are there. With all the three it will give you esters. What are those three reactants? One is carboxylic acid, acid chloride, and acidic anhydrides. Okay, so with this, so acid anhydride structure, if you know, R dash C double bond O, then you have O, C double bond O, R dash. Okay, so this is your acidic anhydride. Okay, so what will happen here? Your this one will break. Okay, so R dash C double bond O, OR you will connect here, and we will get a ester. Clear? So there will be three reactants to give you esters. You can react alcohols with carboxylic acid, or with acid chlorides, or with anhydrides to give you esters. First thing. Another is the reaction with metal, sodium metal. Okay, so here we are done with reaction where alcohols behave as nucleophiles, or where there is cleavage of OH bond. Okay, now we'll go to the cleavage of CO bond. Okay. Okay, now if you see for the first one, HX, reaction with HX. So what happens here, how the reaction proceeds? See, first of all, this O will take this H plus. Okay, so what I will get? So when ROH reacts with H plus, from where we'll get this one? I'll get RO plus H2. Okay, and then we have X minus will attack here, this one will go, and we will get RX. Right, so RX is formed here with water. Okay, now here what happens, there is something called as Lucas test, that is very, very important. So you should remember what we take in Lucas test. We take HCl with anhydrous ZnCl2. Okay, now what happens here? See, the tertiary one. Okay, so this is a test for, so here you can remember, this is used as a test for alcohols. Okay, so here 3-degree alcohols react very fast. Okay, and we get turbidity immediately. Okay, turbidity is found immediately. In 2-degree, okay, it will take in 5 minutes we get the turbidity, and primary alcohols do not give any turbidity. Okay, so this is how you can distinguish between the tertiary, secondary, and primary alcohols based on the Lucas reagent. What is Lucas reagent? HCl with anhydrous ZnCl2. Okay, so the tertiary one will immediately form Rx, which gives you turbidity. Secondary one will react slowly, primary will not react at all. Okay, next coming with PX3, so this X can be either Cl or Br, so you can get RCl or RBr. This reaction we have already seen in the haloalkanes and haloarenes chapter, right? Next coming to dehydration, so if you take H2SO4 at 443 Kelvin, or you can even take H3PO4, we will get alkenes produced here. Okay, so alkenes are the product for dehydration reaction. Now in the dehydration, the order is 3-degree alcohols, then 2-degree, then 1-degree. Okay, this also you should remember. What is the degree of order of dehydration reaction? 3-degree, 2-degree, and then 1-degree. Okay, so let us see first. So we have seen that there are 4 reactions under cleavage of CO bond. So the first one is the reaction with HX, right? Second one is the reaction with PX3. The third one is the dehydration reaction, right? 1, 2, 3. The fourth reaction I told you was what? Oxidation reaction, right? So now we will see oxidation reaction. Okay. So you see, first of all, this is very important to understand. Oxidation reaction. See, alcohols can be oxidized. So this is primary alcohol, right? Primary alcohols are oxidized to aldehydes under mild oxidizing agent. Okay, if you use mild oxidizing agent, primary alcohols will be converted to aldehydes. Then aldehydes can be further converted to acids using strong oxidizing agent. Now from here to here, okay, from primary alcohols to acids can also be done using strong oxidizing agent. Okay, so remember, primary alcohols can be converted to aldehydes using mild oxidizing agent. Primary alcohols can be converted to acids using strong oxidizing agent, and aldehydes to acids will further be converted using strong oxidizing agents. Clear? Primary alcohols can be converted to aldehydes using mild oxidizing agent. Okay, primary alcohols can be converted to acids using strong oxidizing agent. Okay, I'll tell you what is mild oxidizing agent and what is strong oxidizing agent. We'll see that in a while. Now see, so you can see here, this is primary alcohol, right? Now primary alcohol using CrO3, remember the reagents, using CrO3 we get RCHO. Okay, so this is a mild oxidizing agent. The primary alcohols are getting converted to aldehydes. Now if you take a secondary alcohol here with the same reagent, you will get a ketone, right? So what is the conclusion here? If we take primary alcohols under mild oxidizing agent, it will give you aldehydes. If you take secondary alcohols with mild oxidizing agent, it will give you ketones. Okay, so similarly here you can see this is primary alcohol, right? Primary alcohols can be converted to aldehydes using another mild oxidizing agent, that is PCC. Okay, similarly here also secondary alcohols if you take, that will also work. So I can write here, if I take if I take a secondary alcohol with PCC, then I will get a ketone group. Okay, so primary alcohols and secondary alcohols will give you, primary alcohols will give you aldehydes on mild oxidation, secondary alcohols will give you ketones on mild oxidation. I hope this is clear. So what are the two reagents we saw to convert primary alcohols to aldehydes? PCC and CrO3, chromium oxide. Okay, next we have another, this one, copper at 573 Kelvin. So what does this one do? This one converts primary alcohols to aldehydes as usual, secondary alcohols to ketones as usual. So this is your aldehydes, this is ketones. Okay, now this is important here, the tertiary alcohols, okay, tertiary alcohols are converted to alkenes. Okay, tertiary alcohols are converted to alkenes at copper 573 Kelvin. Okay, now your question may arise that what about tertiary alcohols in chromium oxide and PCC? So tertiary alcohols do not react with CrO3 or PCC. Okay, but copper at 573 Kelvin converts tertiary alcohols to alkenes. Okay, so what happens here? You can just see there is one H here. At this OH and this H will vanish, like will be removed as dehydration, and we will get a double bond here. Okay, so now this reaction is also done. Okay, so let us just have a quick revision what we have studied. See, for alcohols we have two types of reaction. One is where there is cleavage of OH bond. OH bond will break. Another where there is cleavage of CO bond. Right? First, these things you should keep in mind. Next, under this heading where we have the cleavage of OH bond. Okay, here we have two types of reactions. One is reaction with metals. Okay, so if you have with sodium, we will get RONA plus H2. Okay, and the next one reaction that we have is esterification. Okay, esterification can be done with what all reactants? One is your RCOOH, R-COOH, next you have R-CO whole 2O, and next you have R-COCl. Acid acid chloride and hydrides, and all these three will give you what? Esters. Okay, so these two reactions we have studied under cleavage of OH bond. Now coming to cleavage of CO bond, here the first reaction is with HX. Okay, here we get RX, and here you should remember about Lucas test. Okay, what is Lucas reagent? HCl and anhydrous ZnCl2. Which one will react fastest? Tertiary will react, secondary will react with some time, primary will not react, right? Tertiary, secondary and primary alcohols. Now the second reaction with this one is your PX3, right? That will give you RX, very simple one. Next one is your dehydration reaction. So for dehydration, what is the order? 3 degree, 2 degree and 1 degree. What are the reagents for dehydration? Concentrated H2SO4, or you can have H3PO4. Okay, and the next very important one is your oxidation reaction, right? So for oxidation, primary alcohols are converted to aldehydes, secondary alcohols are converted to ketones. What is the reagent used for this one? You can use CrO3, or you can use PCC, or you can use copper at 573 Kelvin. Right? Now copper at 573 Kelvin can react with tertiary alcohols also, right? So I can write this one like this. I'll just add here this point. Tertiary alcohols with copper at 573 Kelvin will give you alkenes. Right? So this is all we have discussed. One more thing I told you, that primary alcohols under strong oxidation can convert it to acids, right? If you do mild oxidation, they will get converted to aldehydes, but if you use strong oxidation, they will get converted to acids, right? So what are the strong oxidizing agents that you should know? So here we have strong oxidizing agent as KMnO4, okay, K2Cr2O7. You can have these two reagents are strong oxidizing agents which will convert primary alcohols to acids. Okay, so I'll note down here also strong oxidizing agents. What are there? KMnO4 and K2Cr2O7. Got it? Okay, so I hope this complete. We have revised all the reactions of alcohols. Let us do once again. Okay, the more we revise, more we can remember. Alcohols can show two types of reaction, where there is cleavage of OH, where there is cleavage of CO bond. When there is cleavage of OH bond, it is behaving as a nucleophile. When there is a cleavage of COH bond, it is behaving as a electrophile. Here we have two types of reactions with metals and esterification reaction. Here we have four types of reaction. The first one is reaction with HX. Here you should study about Lucas reagent. Then we have reaction with PX3, PX5, SOCl2. These all will work. Then we have dehydration reaction. What are the reagents for dehydration? Concentrated H2SO4 or H3PO4. Then you have 3 degree, 2 degree and 1 degree. The order of dehydration. Next you have oxidation, very important. From here questions are asked. So oxidation, remember, primary alcohols will give you aldehydes under mild oxidation. So what are the reagents for mild oxidation? CrO3, PCC or copper at 573 Kelvin. CrO3 and PCC will convert secondary alcohols to ketones, copper at 573 also. But tertiary alcohols can only be converted to alkenes, that too by copper at 573 Kelvin. Now if you want to convert primary alcohols to acids directly, so we need strong oxidizing agents like KMnO4 and K2Cr2O7. Okay, fine. So next, coming to one question here. Okay, so this question will help you to revise all the reactions that we have studied so far today. Okay, so first of all is your benzene ring, pH with the H, right? Now benzene ring, if you take CH3Cl, AlCl3, this is your Friedel-Crafts reaction. So what will be A? So if you remember, here one CH3 group will be added. Okay, now NBS is what? NBS adds bromine at the allylic position. So here one bromine will be introduced. So I'll get CH2Br. Next, coming to aqueous KOH. So aqueous KOH converts this Br to OH, right? So what will I get here? CH2OH. Okay. Now see PCC. PCC, this is a primary alcohol. Primary alcohol with PCC gets converted to aldehydes. So what will be D here? So it will be this was like this, CH2OH. Now this part will get converted to aldehydes. So what I'll get here? We will get a CHO. Okay, this is D. Now coming to next one. If you see CH2OH is there, SOCl2. I told you PX3, PX5, SOCl2 all will react in the same way. So this one will give you CH2Cl. Okay. Next, what we are doing? Here adding Cl to H. Here I just forgot one equivalent was given. Okay. That means one more hydrogen will be replaced with chlorine. So we will get here CHCl2. Okay. Now when you do H3O plus, what will happen? This Cl will get converted to OH. So we will get here CH with 2 OH will be there. Okay. And we know on one particular carbon 2 OH is not there, not stable. So what will happen? There will be dehydration and this will give you CHO. Okay. This will give you CHO. After this, now see this one. CHO is getting converted to CH2OH. Okay, CHO is getting converted to CH2OH. In the preparation of alcohols, we have studied that how can reduction of carbonyl compounds give you alcohols, right? Reduction of carbonyl compounds. So CHO will reduce to give you PHCH2OH. So what is the reagent used for reduction here? You can use NaBH4. Okay, so you can use NaBH4 to reduce this one to this one. Now you see this one metal. So this alcohol is reacting with sodium metal, that we have just seen reactions of alcohols with metals. So what will be L here? PHCH2O minus Na plus, right? So this one we will get as a last product here. Now let us do here also. Now see, this is an alcohol and CH3COCl, acid chloride. Alcohols plus acid chloride, just now we discussed, it gives you esterification, right? So what will happen here? We will get this one, benzene ring, then we have CH2O, CO, CH3. Okay. Now this is LaH stands for lithium aluminium hydride. Okay, lithium aluminium hydride. So what will this do? This will convert this part to one alcohol and this one to another alcohol, right? So one alcohol that is produced here will be this one, benzene CH2OH plus this one is there, this part got converted to one alcohol, this one will get converted to another alcohol, CH3 CH2OH, right? So you can see this is already your C, PHCH2OH. Now this is your I. Now if you treat KMnO4, so I is treated with KMnO4. So this is your I. So I told you KMnO4. This is a primary alcohol. KMnO4 is a strong oxidizing agent, right? So primary alcohols get converted to acids under strong oxidation. So what I'll get this one? This will be converted to CH3, CH2, COOH, right? So this is your J. Getting? Okay. So I hope this all reactions, so I want all of you to try this question once again. Okay, just erase everything, write down only the questions and then try this question once again so that you can revise all these reactions again and again. Okay, fine. So now we are done with the reactions of alcohols. Okay, so now we will move towards reactions of phenols. Okay, here certain name reactions are there that we need to remember. Okay, so see, first is acidic nature. Alcohol's acidic nature also I have not discussed yet. Phenol's acidic nature also we will discuss after completing all the reactions. Okay. So next is your esterification. Esterification is very similar to what we have studied under your alcohols reaction. Okay. So this I'll put number 1. This is second. Now third one, electrophilic substitution reaction. Then you have Coles reaction. Okay. Next you have Reimer-Tiemann reaction. next you have reaction with zinc dust, and next you have oxidation reaction. Okay. Now under electrophilic substitution we have nitration reactions and halogenation reaction. Okay. So how many reactions we have written? 7. First is acidic nature, second esterification, third one, this one is electrophilic substitution reactions, fourth one Coles reaction, fifth one Reamer-Tiemann reaction, sixth reaction with zinc dust, seventh oxidation. Once again let us revise. First reaction is your acidic nature. Okay, this is not a reaction, but I'll teach you how to predict the acidity order, but yes, it comes under chemical properties. So first is reaction acidic nature, second one is esterification, which we have already studied, third one is electrophilic substitution, fourth one Coles reaction, fifth one Reamer-Tiemann reaction, sixth one you have reaction with zinc dust, and seventh one oxidation. Once again let us revise. First one reaction the acidic nature, second one esterification, third one electrophilic substitution, fourth one Coles reaction, fifth one Reamer-Tiemann reaction, sixth one reaction with zinc dust, and seventh one is oxidation. Okay. Under electrophilic substitution reactions we have two reactions, nitration and halogenation, that also we will see. Okay. So let us proceed now. So the acidic nature, we can see these two reactions. Okay, reactions with metal. So what happens? H plus goes out, Na comes here, okay, and hydrogen gas is produced. Or you can react with NaOH also. Here what happens? H plus comes out, Na goes here, and H and OH combines to give you water, right? So this is your first reaction, that is reactions with metals, or we can say acidic nature. Okay, under acidic nature we are studying about reactions with metals. Next, coming to the third one, esterification reaction I have written later. So this is the reaction that is with nitration, electrophilic substitution reaction, nitration part. 3A I am putting. Okay, so I will also number here. This is 3A and this is 3B. Okay, so if you see here 3A, so if you take dilute HNO3, okay, so now what is this OH group? OH group is a ortho-para directing group, right? So the NO2 group will be attached at the ortho position and at the para position separately. But if you take concentrated HNO3, then what will be happening here? All the ortho para positions are occupied together. Okay, we will get one like trinitro derivative we will get. Okay, so if you take dilute HNO3, we will get two products, ortho and para. If you take concentrated HNO3, then we will get trinitro derivatives. Clear? Okay. 3A. Next, coming to halogenation. So this is again 3B. These two reactions are 3B. So here if you take only bromine, okay, only bromine, then all the ortho and para positions will be occupied simultaneously. Okay, ortho and para positions will be occupied simultaneously if you take bromine. Now if you take bromine with CS2, Br2 with CS2, then the reaction is reduced, the rate of the reaction is reduced, and we get ortho products and para products separately. Okay. Next, coming to your this one, okay, now this one is the fourth one, that is your Coles reaction. Now in Coles reaction what happens? First you treat it with NaOH, we will get O minus Na plus, that is called. After that if you treat with CO2 and H plus, okay, CO2 and H plus, we get here OH, COOH. Okay, so this is nothing but your Coles reaction, very very important name reaction, Coles reactions. Okay, what is there in the Coles reaction? First you have to take phenol, treat it with NaOH, we will get sodium phenoxide ion. Then we have to treat with CO2 and H plus, so we will get OH and COOH attached to the benzene ring, and that is nothing but your Coles reaction. Okay, so 4 reactions completed. First one, acidic nature. Under acidic nature nothing is there but reactions with metals we studied, so we have 2 reactions there. Okay, then esterification we have left. Second reaction we have not discussed yet, but it is very similar to the first one. I will just show you. The third one, that is your electrophilic substitution reaction. There we have 2 reactions, nitration. If you take concentrated NO2, then all the 3 positions will be substituted. If you take dilute HNO3, then you will get ortho and para separately. And the next one is your halogenation reaction. Similarly, if you take direct bromine water, all the 3 positions are substituted. If you take bromine with CS2, then we will get ortho and para positions separately. Okay, so this is your third reaction, means according to the number. Fourth reaction is your Coles reaction. First you have to take NaOH, we'll get sodium phenoxide ion. Okay, this is sodium phenoxide ion, right? To sodium phenoxide ion, if you treat with CO2H plus, we will get OH and COH, which is nothing but your Coles reaction. Okay, next coming to fifth reaction, that is your Reamer-Tiemann reaction. So if you take first one, OH with CHCl3 plus aqueous NaOH, okay, so this NaOH will take this OH as O minus Na plus, and this CHCl3 is attached here as CHCl2. Okay, then again if you treat it with NaOH, what happens? The two chlorines get replaced with OH, and then there is dehydration and we get CHO here. Then if you finally treat it with H plus, then we get this one. This is nothing but your Reamer-Tiemann reaction. Okay, this is Reamer-Tiemann reaction. Okay, so first what happens? You take phenol, you react with CHCl3 and NaOH. O minus Na plus will form, and to the ring CHCl2 is attached. Again you treat it with NaOH. So this, what happens here, when you treat with this one, we get this compound. See, there is an intermediate like this, and here I get CHOH, OH, right? So here there is a dehydration. Due to this dehydration, I get CHO here. Okay, after this H plus, if you treat OH and CHO, we will get. Okay, that is your Reamer-Tiemann reaction. Okay, Reamer-Tiemann, Reimer-Tiemann, whatever you can pronounce, but the reaction is like this. Okay, next coming to, if you treat with zinc, so this is my fifth reaction, right? This one I'll write here like this. Yeah, this is fifth reaction. Next, sixth one is your zinc dust. So with phenol, if you treat with zinc dust, we will get benzene and zinc oxide. Okay, so directly there is reduction here, and we get zinc oxide and benzene ring. Okay, next the last reaction is your oxidation. If you treat it with Na2Cr2O7, that is sodium dichromate, if you treat with this gets converted to this compound. Okay, this compound is called as your quinone. Okay, clear? All the 7 reactions. We have not yet discussed esterification, that we will discuss. Okay, so now let us do a small recap again. First, what we did, first reaction was with reactions, the acidic nature. Acidic nature, in that we are discussing about reactions with metals, right? So there I saw reaction with Na and NaOH, right? Second is esterification, which we will discuss. The third one is your electrophilic substitutions. Under that we have 2 reactions, nitration and halogenation. Nitration, if you take concentrated HNO3, all the ortho para positions are substituted, and if you take dilute HNO3, then you will get ortho and para products separately. Then 3B, halogenation. Halogenation, if you take directly bromine water, all ortho para will be substituted. If you take bromine with CS2, then we will get ortho and para separately. The fourth reaction is your Coles reaction. Here first you treat with NaOH, so we will get sodium phenoxide ion. After that you treat it with CO2 and H plus, so we will get OH and COOH. Right. Next, coming to the fifth reaction, that is your Reamer-Tiemann reaction. Here we are treating it with CHCl3 and aqueous NaOH. Okay. So here what we will get, CHCl2 is first attached, then again you treat it with NaOH, so this one will get converted to CHO, and finally if you treat with H plus, we'll get OH and CO. And this is your Reamer-Tiemann reaction. Okay. Next, your sixth reaction is your reaction with zinc dust, that will give you benzene and zinc oxide. And the seventh reaction, the last one, that is oxidation, and this one will give you quinone. Okay. So this is all about the reactions. So we have now esterification reaction, which we have already discussed. Under under esterification we can react it with 3 type of reactants. One is your acids, another is your anhydrides, okay, anhydrides, and then with acid chlorides, right? With all these 3 types of reactants, we get esters. Okay, so if you take with this one with this acid, so this part will go, so we will get OCOR dash, and this part and this H will make you water, right? Here we will get OCOR, and then another acid will form. And here if you take, we'll take this RCOCl part, okay, and this HCl will form as another byproduct. Okay, that is the first thing. Now here you can see this is another example. If you have COH and OH, right, this product we will get in Coles reaction, right? If you do Coles reaction, we can get this product. Now if you react it with this any anhydride, we will get OCOCH3, right? And this product is nothing but your aspirin. Okay, so you must remember the name of this compound, OCOCH3 with COOH. This will give you aspirin. Okay, so this is important one. This reaction is important, so please remember this reaction. Okay, so yes, that's there. Okay, now we will talk about the acidic nature of alcohols and phenols, how to predict the acidic nature. So now you see that first point, whenever you need to predict the acidic nature, step 1 what you should do, remove H plus and remove H plus. After removing whatever is left, that is called as conjugate base, right? Remove H plus to get the conjugate base. Okay. Step 2 is compare the stability of conjugate base. Okay, so here how to compare it? Now see, if there is electron withdrawing groups, then conjugate base is very stable. Okay, so I'll just write like this. If electron withdrawing groups are there, okay, then conjugate base is highly stable. If conjugate base is very stable, then more acidic. Okay, next in the same point we can write, if electron donating groups are there, then what will happen? Conjugate base is unstable. Okay, conjugate base is unstable, that means it is less acidic. Okay, now let us take one example for this. Suppose you have this 3 compounds. Phenol is there, okay, then I have OH with NO2 group, and next I have OH with OCH3 group. Okay, now see here. Okay, now NO2 group, so first step is what? Remove H plus to get the conjugate ions, right? So I can remove this H plus from all of these options. So just remove H plus, then only we can, so now we'll get O minus here. Okay, these all are conjugate bases. Now you need to find the stability of this conjugate bases. Now see, this is a what? Electron withdrawing group, and this is a electron donating group. Okay, so I told you electron withdrawing group will stabilize the conjugate base and the acidity will increase. Electron donating group will destabilize the conjugate base and the acidic nature will decrease, right? So that means this conjugate base is very stable, right? So its acidic nature will be highest. So suppose if this is A, this is B, and this is C, then I can say that B is more acidic. Okay, and then here there is no group. Here there is something which will decrease the acidity, right? So if you compare A and C, A will be more acidic because here there is decrease in acidity due to the presence of electron donating group, right? So what will happen here? B, A and C. This is the correct order of acidic nature. Now here sometimes questions are also asked with respect to pKa order. So remember, acidic, if the compound is more acidic, highly acidic, high acidic means less pKa value. Okay, so if pKa value is asked, if some compound is very highly acidic, then its pKa value will be least one. Okay, I'll show you questions with this also, but you have to remember that if acidic nature is very high or it is a strong acid, then pKa value will be less. Okay, so this is all about the acidic nature. So now we will do some question. Before that, I gave you a homework question in my last class. Okay, I think all of you would have answered it. Very simple question, that was solubility of phenol in water is lower. This can be attributed to. So that is your non-polar nature of phenol, the acidic nature of OH group, non-polar hydrocarbon part in the phenol. Okay, this hydrocarbon part is very big. That is why that benzene ring, it is less soluble as compared to alcohols. Okay. Okay, now coming to today's questions. We have 10 questions. So many of you might think that whether this lecture that we are studying, which in this course we are doing, whether it is useful or not, whether it is sufficient or not. I get a lot of comments like this, right ma'am, whether it is sufficient to read whatever you are teaching or not. So the only way to check this, okay, to solve PYQs, whatever lectures we are covering, just read those lectures and start attempting the previous year questions. If you are able to solve these questions, then you are on the right track. Okay, so that is the only way you can measure, you can test that whether the things that we are teaching you are able to solve the previous year questions with that knowledge or not. Okay, so whatever we have discussed today, based on that I have taken 10 PYQs. Okay, let us try to solve each one of them. Okay, a better reagent to oxidize primary alcohols into aldehydes. Okay, so primary alcohols into aldehydes, we have discussed that primary alcohols can be converted to aldehydes under mild oxidizing agent, and for mild oxidizing agent we had PCC and we had CrO3 and we had copper at 573 Kelvin. Okay, now these two are strong oxidizing agents, right? Now question may arise, what is out of these two, which one will happen, because both are there. But remember, it is asking a better reagent. Okay, so better reagent is always PCC. Okay, because chromium oxide, if you provide some acidic medium or some other little medium is changed, it can behave as a strong oxidizing agent also sometimes. Okay, so better reagent will be PCC. Clear? Okay, next. The next question is here, OH and NaOH. First, this one also we have studied today, reaction. What it will give you? O minus and Na plus, right? This is A. Then CO2 and H plus. You remember, this is Kolb's reaction. So what I will get here? We'll get OH and COOH, right? This will be B. Next you have CH3CO whole 2 H plus, right? So this one will get esterification, will get OCOCH3 and we have COOH, right? So this product I told you, must remember, this is an important compound. What was it? The name of this compound was aspirin, right? So this is your aspirin. Okay, so the correct answer for this question will be option number B. Okay, next, an organic compound with molecular formula C7H8O. So when you get compound molecular formula greater than 6, okay, C6, more than 6 carbons are there, immediately you can think it can be a benzene ring. Okay, dissolves in NaOH and gives a characteristic color with FeCl3. On treatment with bromine, it gives a tribromo derivative C7H5OBr3. The compound is, okay, now see, we have C7H8O. So there is one OH and there is one CH3. Okay, now see, the CH3 can be present here, can be present here and can be present here. Okay, these are the 5 positions where CH3 can be present. Now when the next treatment is staying, on treatment with bromine, it gives a tribromo derivative. So if you remember, phenol, when it was treated with bromine water, if you treated it, we got this product, right? OH, Br, Br and then Br. We have to attach one CH3 here. So that means if tribromo derivative is obtained, that means CH3 cannot be present at these 3 positions, right? These 3 positions are not there where CH3 is present, because when you treat it with bromine, tribromo derivative is obtained. That means CH3 must be at the meta position, right? And this is nothing but your metacresol, right? So correct answer for this question will be option number A. Okay, very tricky question but good one. Next, In Kolb's reaction, the reacting substances are, Kolb's reaction, let us revise again. What was Kolb's reaction? First you take OH, then you treat it with NaOH, then we used to get O minus, Na plus, then you treat it with CO2 and H plus, and we used to get OH and COH, right? So what was the reagents there? Sodium phenate, this is sodium phenate, and you have CO2. Sodium phenate and CO2 will react in the Kolb's reaction, okay? Next, match the following acids with their pKa value. So this is again important, and here what you have to remember, that more acidic, if the compound is more acidic, that means it has low pKa value. And when we will get more acidic, if we have electron withdrawing groups, right? This one we discussed, okay. Now you see, first we have phenol, nitrophenol, ethanol, picric acid, okay. So if you see picric acid structure is like this, OH, and we have 3 NO2 groups here. So it has 3 electron withdrawing groups, right? 3 electron withdrawing groups are there, means it is very highly acidic compound. If it is very highly acidic, its pKa value will be very least, right? So I can say that D1 will be 0.782, okay? So I have 2 options with 2, so I can eliminate these 2 options, right? So we can eliminate option number B and D, okay. Now let us check about para-nitrophenol. So nitrophenol means what? It has only 1 NO2 group, that it is next more acidic, so its pK value should be something greater than 0.78. So next number greater than 0.78 is 7.1, right? So I can say that for B it is 4. So if you check here, for B it is 4, and for here it is B is 1. So we can eliminate this option. Correct answer will be option number A. But we'll check all the options, okay. Now phenol will have the next one. So phenol can have of 10, right? So A will be 3, okay. And ethanol is CH3 CH2 O minus, right? Here you see there is no electron withdrawing group, so it will be the least acidic. The conjugate base is very unstable here. It is least acidic and should have the highest pK value. So C will be 1, that is 16. Clear? Okay. Next, phenol can be distinguished from ethanol by the reagent. So see, phenol, if you react phenol with bromine water, we will get tribromo derivatives, okay, and it will form a different compound, whereas ethanol will not have any such reaction. So it can be differentiated using bromine water, okay. Next one, when the vapors of tertiary butyl alcohols are passed through heated copper at 573 Kelvin, the product formed is. So I told you our speciality about copper at 573 Kelvin, it even reacts with tertiary alcohols, whereas PCC, chromium oxide, they do not react with tertiary alcohols, but copper at 573 Kelvin reacts with tertiary alcohols to give you alkenes. So they will give you, so this is your tertiary alcohols. I'll write like this. Okay, so there will be dehydration and we will get CH3, CH3. Okay, so if we number this, I'll get 1, 2 and 3, right? So 2-methyl propene. Correct answer is option number C. Okay. Next, what is the increasing order of acidic strength of the following? Okay, first let us draw the structure. Para-methoxyphenol. So we have this one. This is para-methoxyphenol. Next we have para-methylphenol. We have para-methylphenol. Then we have para-nitrophenol. Very important question, this one. Important question. Let us see. First step is identify whether it is a donating group or an electron withdrawing group. Okay, first step is that. So OCH3 is a electron donating group. CH3 electron donating group. NO2 electron withdrawing group, right? Now, if electron withdrawing group is there, acidity will be more. So definitely I can say that the third one acidity is highest, right? So you can see there is only one option where the third acidity is highest. So I can tell that answer should be option number C, okay? But we will check, we'll discuss how it is happening. Now see, so this one is out. Now we have these two electron donating groups will decrease the acidity, right? Now how are they donating? See, for donation or for withdrawing, either for donation or for withdrawing, okay, either for donation or withdrawing, there are two ways. One is your plus or minus I effect, another is plus or minus R effect, right? Resonance and inductive effect. And always remember that resonance effective is more dominant, okay? This is always more dominant effect. So now what happens? See, so that means this one will also donate, okay, this one will also donate, but this one will donate by plus I effect, okay, CH3 has plus I effect, and this one donates by plus R effect. So where donation will be more? Here donation is more donation, that means less acidic, okay. Here also donation is there, but here it is less donation because it is donating by plus I effect, less donation, so it is more acidic, okay. So comparatively, if you see this one, then this one, and then this one, so option number C is the correct answer, okay. Next, products X and Z in the following sequence are, okay. First one, you have phenol with this one AlCl3, Friedel-Crafts alkylation will take place. So this one will give you this, we will get isopropyl benzene, this is your X, okay. And then if you treat it with O2, so with O2 what I will get? With O2 we will get, okay, this product will get, this is your Y, okay. Then if you treat with H plus H2O, then we will get phenol and acetone, okay. So here what we will get? The product X and Z. So Z is definitely acetone, so we have these two options, we can eliminate option number C. Then you have option number, this is first one, that is your isopropyl benzene. So isopropyl benzene and acetone, correct answer is option number A, okay. Next question. So this question is from your preparation. See how direct question from preparations have been also asked in the examination. Next, which of the following cannot be used to oxidize primary alcohols to aldehydes? CrO3 we can use, PCC we can use, KMnO4. I told you KMnO4 will oxidize primary alcohols to acids, not to aldehydes. So cannot be used, option number C. This one cannot be used, okay. Okay, so yes students, so this is a homework question for you, okay. Just try this question, acidic order you have to try and comment down the answers, okay. So students, today's class was very important and all the important reactions we have discussed. So I hope that you have practiced this, like you have understood the reactions, and if you have any doubt in any of these questions, do not forget to comment down, I'll definitely address it, okay. Thank you for watching, and please be with us for this whole series so that we can hit that perfect 60 score in the KCET 25 examination, okay. All the very best, and do not forget to subscribe the channel, and do not forget to join the WhatsApp channel. Thank you for watching, and see you soon in the next class of alcohols, phenols and ethers.